Hi, in this video we will learn about composition of two functions. This is another way to generate a new function out of old functions. So then let us assume that there are two functions, let f and g be two functions on the real line. Means that the domain and the range are subsets of real line. Then the composition of f and g, which we denote by FOG, denoted by FOG, not just FG. FG is product. FOG is a function defined as, so FOG at x is you evaluate the function which is closer to x at x, then that's a number. Yes, gx at a given point x is a number. Then you plug it into f. So that's how you, so first evaluate function g at x. The outcome is a number. You plug it in f and then evaluate f at gx. Well, one nice picture that can help to understand the composition of two functions is that, remember that we had this picture in mind that a function is like a machine. It has some input and it has some output. If you have another machine, let's say this is the function g, and there's another machine, let's call this one f, and this one also has a function, the input and output. Yes, now we want to make a bigger machine using these two by connecting the output of g as the input of f. So what we do is that we basically take the output of that guy g and put it as input of g. And well, one can say that this basically gives us a large box, a large machine. We call that guy FOG. How does FOG work? Well, you put x into FOG. What happens is that inside, x goes first into the machine g. The outcome comes is gx. And then gx is put into f as an input, and then the outcome will be f of gx. And that's how you can have a picture in mind that how this composition work. Okay, let's do some examples. Example, use the following table of values to find the given values of composition function. So we have this value function, two functions we have actually. One is fx, one is gx. The values of x are 0, 1, 2, 3. Values for f at 0 is 3, and then at 1 is 0, at 2 is 2, and at 3 is 1. G at 3 is at 0 is 1, at 2 is at 1 is 2, at 2 is 0, and at 3 is 0. Then the question says find f o g at 1, find a g o g at 0, find g o f at 2, and find f o f at 3. Different functions, yes. One of those functions can be, well, someone can use both of these ones. So what the rule was, what? When you trying to evaluate composition function at a point, first evaluate the function which is closer to that value, so g at 1, then evaluate the function further away at that point, and then that is f at g at 1. G at 1 is 2, and well, now we can evaluate value of f at 2, which is 0. How about GOG? So at 0, first thing is that find the value of the function closer to that number, and then evaluate the outer function in the value of the inner function. So this will give us g at 0 is 1 here, and then g at 1 is 2. So GOG at 0 is going to be 2. How about GOF? This is going to be g of f at 2, but f at 2 is 2, and then g at 2 is, g at 2, the table has it, it is just 0. How about FOF at 3? So it is f of f3, and this is f of f at 3 is 1, and f at 1 is 0. So that's how you find the values of the compositions at different points. Well, the point is that this can be done in a more general way. So example, let f of x be 1 over x, and gx be x squared plus 2. Then find what is FOG, what is GOF, how about FOF, and GOG at x. Well, let's see. FOF at x is f at gx, and f at gx is, well, gx, we have the formula for that. And what does this say? The function f is defined this way. Whatever you give to f, it will return inverse of that. So here now it is f of x squared plus 2, so that in return we will get inverse of that. So that is the formula for FOG. How about GOF? Well, g at f of x is how the composition is defined. Now g of f of x is 1 over x, and g of 1 over x, you see g says whatever you give to me, I will square it first and then add a 2 to that. So now here we are putting in 1 over x. It will square it first and then add 2 to that. Well, we can simplify that one definitely. X squared plus 2, which will give us 2x squared plus 1 over x squared. F of f. So this is f at f of x. F of x is 1 over x. Now, f of 1 over x would be 1 over x. Again, remember, you have f of whatever you give to f will be inverse of that. Here now we are given 1 over x, it will be inverse of that, and you can see that you can multiply, simplify that and get x. And g, og here will be g of gx, and that gives us, well, g of x squared plus 2, which is the same thing as, well, x squared plus 2 squared plus 2. Well, you have to not only know how to find the composition, you also need to know sometimes do the other way around, kind of decompose this thing. So example, find two functions f and g such that the given function is f o g of x. So the first one, now we are going the other way around. The function is given, so we want to find what are the functions that when you compose, you get this one. The second one is hx equals to x minus 1 over x plus 1 squared. And the third one is h at x is okay. Let's see. For this one, you see that when you plug in x, what happens is that first function finds x squared minus 4x, and then find square root of that. So it maybe then this gives us an idea. If under the square root we take it as gx, this is composition of, so under the square root is x squared 4x, and if we take f of x to be a square root of x, this means that we have found f of gx. So for gx equal to x squared minus 4x, f of x is root x. Again, everything starts from this point that while evaluating this root of x squared minus 4x, you notice that we do first evaluate this piece and then find the square root. And that tells us that how these two functions are composed to give us the function h. Here, again, you see that the operation is done here and then find the power of that. So this is gx to the power 2. And, well, gx in this case is x minus 1 over x plus 1. And the second operation after evaluating at x is squaring. So that means that the outer function is x squared. So that when you combine that with g, you get gx squared. this one is a little bit trickier one. What you can see here is that you see this piece here. What does it do? So it sends x to third root of x plus 1, yeah? But outside part is also like that. So you have 1/3 root of this box plus 1. So maybe that's the idea, that this is a function which is composed by with itself. So in this case, gx is the third root of x plus 1. And then fx is again the same, the third root of x plus 1. This might be a little bit trickier to understand, but try to see that this is actually that. So basically, f o f, well, in this case, f and g are the same thing, is f of the third root of x plus 1. And then this means that you have the third root of x plus 1 plus 1, and this is the third root. Well, in this video, what we learned was the definition of the composition. What does it mean you compose two functions? The new function defined this way, how does it work, how we can evaluate that, and then we did some examples for the compositions of functions.